All right, welcome to Distance Learning and Worksheet 0, which is intended to be a review of law of sines and law of cosines that was taught in advanced algebra. So, first things first, we want to make sure that we understand our calculator settings in that we know when to be in degree versus radian mode. So just a quick check, make sure you know how to do that. So when you go into a document, you can see up here in the upper right corner that we're in degree mode, and that's great if we're going to deal with something like 45 degrees or 30 degrees or what have you. But maybe we want it to be in radians, so maybe we want to deal with like pi over 6 or pi over 4. So just to make sure you know how to do that, you should be able to go back to your home menu in your settings, and then in document settings, this is where you change that angle. So if you want it in radian mode, just press OK, and then now when we go to a document, you can see it says RAD up there instead. Okay, so just to make sure we're aware of that, and also just another thing, just to make sure we've got some handle on it too. Back in geometry, when you did triangles, we always used capital letters for angles. So this is like angle A, angle B, and angle C. And then lowercase letters were for the sides, and they're always associated with the opposite side. So this would be side A over here, this would be side B, and this would be side C, because again, they're across from each other. Okay, so just a little basics here at first. Then we'll just have the two different laws here written for you. Here's the law of sines. The law of sines is this set of ratios. Again, we generally only use 2 at a time rather than 3, but what we're doing is we're just going to say that the sine of an angle divided by its opposite side is the same ratio of sine of another angle to its opposite side. Law of cosines. So we got this one over here. Law of cosines is the following. You take again. You take the side you may be trying to find, squaring it equal the other two sides squared. The sum of those two minus 2 times these two sides times the cosine of this angle. So you notice that side and the angle are always matched up. The way I like to remember this is the law of cosines is best used if you're given this type of a triangle, or you're giving an SAS triangle. So going back to geometry and remembering those pieces, that if you're given a side angle side triangle, so if you're given a side, this side is 7, this angle here maybe is 30 degrees, and this side was 6, so you're given a side angle side triangle, or you're given a side 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 triangle, so maybe this is 7, 6, and 5. All right. Law of sines is best used when these kind of triangles are given. Or generally what I like to remember is if you're given an angle, so maybe that's like 70 degrees, and you're given its opposite side, so maybe this side is 5. So I always like to see that you got a matching set. You got an angle and an opposite side. Like over here you see you can't do that. So that's how I remember that. So when you look at this, actually the way this is lined up for this problem right here, this is a side side side, so I would be using the law of cosines for this one. So law of cosines I'd use for this triangle. This one over here, I notice I've got an angle and its opposite side that are given. So that's where I would use the law of sines. I'd use the law of sines for this one. So let's do that. Let's give this a practice, and we'll do these first 2 problems and then take a look at what we got left with the time we got remaining. So I'll just keep that up here on the top so we can see how that's used, and we can go ahead and try this problem. So if I'm trying to solve for a piece here, then obviously I have to be solving for one of the angles here. So let's just say I'm solving for that angle right there. So again, what I'm going to do is, again, using this law up here, I'm going to match the angle here with its side. So I'm going to match this angle here with its side. So that's the side I'm going to start with. So I'll just go 12 squared equals the other two sides squared. So 18 squared plus 21 squared. Then minus 2 times 18 times 21. So you take those two sides and multiply them together. Times the cosine of that angle that's associated with that other side. And we don't know what that is. Doing a little math here, and I'm going to do this a little quickly here. And the one thing I'm going to talk about here is just make sure we do keep order of operations here. So we're going to square these things before we do any multiplying and subtracting. So I'm going to square this, which is 324. 21 squared is 441. Okay, so now I've got that squared. Now I can do the multiplying. So I'm going to go minus, and then it's 2 times 18 times 21 comes out to be 756. And we've got times the cosine of theta. Now here's where people are going to make the big mistakes. And I'm going to warn you this ahead of time. They're going to go 324 plus 441, then minus 756. Now the 756 is attached with that. That's sort of like doing, if I said 3 plus 4 plus 5x, and people go 3 plus 4 is 7 plus 5 is 12, and this answer would be 12x. Well, we all know we can't do that. We can only add those like terms first. So just remember, we can only add these together, can't combine it with this. So 324 plus 441 is 765. Then this is minus 756 times the cosine of theta. I would then subtract 765 from both sides to get negative 621, which would then equal negative 756 times the cosine of theta. And now I'm going to divide by negative 756, so I'd have cosine of theta equals, and negative divided by negative would be a positive, so this would be 621 over 756. And what I'm going to do now here is just to find out what that theta, I'm going to take the inverse cosine of both sides. So that would give me theta equals the inverse cosine of 621 over 756. Now I recommend not changing that to a decimal. You got the exact fraction right there, so we can then use our calculator. And if I want to get this in degrees, I go to my calculator and again, make sure I'm in degree mode. So I'm going to go back out to that home menu, change those settings, document settings, and put that in degree mode. So now, when I go back to that screen, notice it's in degree mode. So now when I do the inverse cosine, so if I go trig, inverse cosine, and inside here, do a control divide for the fraction, and then go 621 on the top, and 756 down on the bottom. That's about, if I round to the nearest degree, 35 degrees. Okay. All right, let's try using the law of sines over here with this problem, because again I got that matching set. Okay. That's what I'm always going to start with. So I'll just start over here with a sine of 22 degrees is to 13. Now the other one I'm going to pick is the one here that's already got the side, and I'm going to go and try to find that angle right there. So I'm just going to say I don't know what that angle is. I'll just call it some theta. So I'll go sine of theta over 15. And now this is just doing some cross multiplying. So 13 times the sine of theta equals cross multiply the other way, 15 times the sine of 22 degrees. Divide both sides by 13, so I'd have sine of theta equals 15 times the sine of 22 degrees all over 13. And again, I'm not going to do any math there yet, because now I know I just have to do the inverse sine to find out what theta is. So I'm going to take the inverse sine of all of this up above here. This 15 times the sine of 22 degrees all over 13. And then just type that into my calculator. Again, let's find it in degrees, because I know that my calculator is already in degree mode. So I'm just going to go inverse sine and go control divide to get that fraction. On the top part, it was 15 times the sine of 22 degrees. And again, if it's in degrees, that's what that number is thinking, so it's in degrees. And on the bottom was 13. If I press my enter, if I round that to the nearest degree, it'd be 26 degrees. Okay, now what these other what these other problems do is they want you to find those indicated parts of the triangle using either law of sines or law of cosines to find those pieces. Maybe this one down here might be a little interesting because it's got a 90-degree one in there, so maybe we could use a little SOHCAHTOA. If you remember that, we'll review that in our next lesson, on the worksheet number 1. Maybe some Pythagorean theorem could also be used for that as well. The other problems here are just, it says solve the triangle. So when you say solve the triangle, that means to find all missing parts. So at that point, what you can do is probably start off using law of sines or law of cosines. You have to do one of those. And a lot of times then too, if you can find out like what this missing angle is, well then we'd know that we can get that third angle by doing 180 degrees minus those two other angles. Pythagorean theorem is also certainly a good tool to use. But it has to be a right triangle in order to do that. And same thing as I mentioned a little earlier, if you know this ahead of time before we go into worksheet 1, maybe you can use a little SOHCAHTOA as well. But again, that would have to be a right triangle for you in order to do that, so it wouldn't work in these kind of problems. So, give this a try. We got several problems here for review. Using the law of sines, law of cosines, again looking for the idea that if you have a matching set, use the law of sines, or like here we don't have a matching set, use the law of cosines. So try to find start one of those missing parts. Like here we have the first 6 problems, we're just finding the x part and then going from there. Alright. Good luck finishing this, and we'll see you at the next worksheet.